And now it's time for
a tiny bite
of knowledge. In a world with 32 and 64-bit software,
enter in the byte. That's byte with a Y.
roar.
Roar. So Jody, what is a byte? When we're talking about computers, what is a byte?
A byte is a measure of digital storage. And typically what this means is that one single byte is equal to 8 bits.
And a byte usually represents a single character, such as a letter, a number in computer language.
And fun fact, so like these 8 bits, what those bits refer to are like the binary zeros and ones, right? So like if you really break it down, or you think about like the Matrix where they've got a bunch of zeros and ones floating down on the screen, all those little 0 and 1 binaries, each one of them is a single bit.
And 8 of those equals a byte.
Yeah.
You commonly hear about bytes used for computer memory or storage terms. So, I mean, it's pretty often that those of us geeks in precision agriculture are sitting down and we're going, hey, how big is your storage there? Do you got a 64 gigabyte, 1 terabyte, 2 terabyte? And over in Halstead, we even talk about having a petabyte of storage on our servers for imagery data.
How many gigs of storage is a petabyte?
Let's start by backing up and talking about how much is a kilobyte. So you've got a byte, then you've got a kilobyte. That's 1,000 bytes. Then you've got a megabyte, which is 1,000,000 bytes. You've got a gigabyte, which is 1,000,000,000 bytes.
And then a terabyte. A terabyte is 1,000 gigs.
Mm-hmm.
Or 1 quadrillion bytes. And a petabyte is 1,000 terabytes.
1,000 terabytes. I mean, I'm thinking about like, I've got a USB stick here that's sitting with 1 terabyte of data. That's a lot of storage.
You have a USB stick with 1 terabyte storage?
Mm-hmm. Yes, I do.
That's amazing.
Isn't that amazing? It is amazing. Yes, very amazing. We've got a lot of stuff on there. Lots of pictures. It's great. But it's still a terabyte. And a petabyte, you said, is 1,000 terabytes?
1,000 terabytes.
That's a lot. Now, on that petabyte of storage, we actually have our data on the servers backed up. Yes, we do. But you got to realize, to put things in context for what's over there for data, I think we're currently missing, what is it, Jody, 8 states in the United States for data on those servers?
Something like that.
So we have the majority of the United States on there. We've got at least 3 provinces in Canada, and we're talking Alberta, Saskatchewan, and Manitoba. So provinces that have rather large land masses to them. The data that is stored up there includes any shapefile formats that help show us where township sections, ranges are located, as well as all of the, for example, NAIP imagery that we would have in the United States. That's a United States program. Unfortunately, in Canada, you're not going to have that. But those are images that are flown once a year or once every 2 years. It's very detailed imagery, and it takes up a lot of room, especially these newer images as the newer imagery is more detailed and contain more bands of light than the old ones used to. We also have over there, Landsat data that's 30-meter resolution, and that goes, those libraries go back to like 1984. And we've also got Sentinel data that's 10-meter resolution.
Okay, so we've got a lot of storage.
A lot of storage. You could even say we took a byte out of storage.
So even though you and I do tiny bytes, the GK office has a big byte of storage.
It's like a monster.
Monster byte.
It's a monster byte over there. Let's back up though and talk about that petabyte that's over there. So as I was saying, we've got all of that NAIP imagery. In addition, we've got Lidar data. Some of that data, and we pretty much have got Lidar data for wherever our clients would have asked for it around the United States. We also have 2 different libraries of satellite information. Landsat data that goes all the way back to 1984. Those images were not recorded as frequently throughout the growing season, and it's 30-meter resolution data, but it goes back to 1984. Whereas on the Sentinel data library, we have more images in season. That library only goes back to about 2016, maybe 17, right in that range. And that data is 10-meter resolution data. So it's more detailed than that Landsat. We have more images, more detail, but fewer years for the Sentinel data. And the Landsat library has a much longer history to it and less detailed and fewer images during the growing season. And really, when you start thinking about all those imagery components, that really starts adding up to what is using the data on our servers over there. And in case you are an ADMS user, when you go into our servers to download data to make drainage maps or to make zones, you are going into that server and getting those data out of there.
So of course, like with the Landsat images versus the Sentinel, because Landsat is less detailed, it's got a lower resolution, so 30 meters versus 10-meter resolution. It's going to take less bytes of storage for each of those Landsat images versus Sentinel, correct?
The more detailed the images, generally speaking, the more data it's going to take to store them. And that's something we need to really think about in precision agriculture. So we think a lot about satellite imagery and those comparisons that Jody's just making between Landsat and Sentinel data. One of the things that we need to think about is this push towards going to drones, because those pictures that are coming off of drones take up a pile of space. Yeah, we can run them in our software and work with them in our software, and that's great. But boy, you put one image on a 1 terabyte jump drive, and it doesn't take a whole lot, very many images to take up a lot of that space. So space and what exactly a byte is, what exactly a terabyte is, a megabyte, gigabyte, petabyte, it's interesting to really think about and the challenges that come along with that storage. So this might be a tiny byte. Over in Halstead, we have a
petabyte,
which is a monster byte.
Tune in next time for a tiny bite of knowledge
from GK Technology,
where we have a map
and an app
for that.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.